Okay, picking up where we left off from the last set of videos, this is going to be problem number 3 and 4 in Exam 2 Prep. In both cases, we're using the disk method to evaluate the volume of a region. Now in number 3, we have a picture to work with, and we're being told that we're revolving this region around the x-axis. So right off the bat, we need to recognize that the integral to use the disk method revolved around the x-axis requires us to write the integral with respect to x. So that tells me that our boundaries have to live on the x-axis as well. So we use boundaries of integration from 0 to the natural log of 3. And inside this integral, we need an area formula as a general reminder. So the area associated with this region's rotation, well, that's just going to be a circle. And we can compute the area of a circle with pi times radius squared. The radius of each of these circles, however, is simply the y component of the position on each of those circles, and that y component is established by this equation. So e to the negative x squared power. So I've set up the expression in my TI calculator, and we'll tap enter. There's our precise result of 4 pi over 9 and an approximate result of 1.3963. And here again, when we're computing, or I'm sorry, when I'm checking your work, I'm looking for 2 or 3 things. The setup, what you did to put into the calculator, and your results from the calculator. And I am interested in precise and approximate results. Moving on to number 4, we're again using the disk method to find the volume generated here. Now, we're being told again that we're revolving about the x-axis, so right off the bat I'm thinking integral with respect to x. We know that we have a function that's going to create our boundary line, and that function is only going to be investigated between 0 and pi. So even though I don't have an equation, or I'm sorry, a picture of the equation to work with, I'm still going to rely on the fact that this boundary has to be a pair of x values, so we'll integrate between 0 and pi. In general, the disk method is going to create a circle with pi times radius squared, and the radius has to be 11 sine of x. Now again, this problem is pretty clear in saying that we're using the disk method, but we should also remember that the disk method and the washer method are really closely related. The washer method requires a slightly different approach, however, where we're taking the square of 2 different functions. But again, since this region is not going to create a hole, well, we know it's not going to create a hole because there's not another function. We're only given one y function here. So it's going to be solid in the center. I feel confident with this equation. And I've got the results set up in my calculator. Again, there could have been some algebra that we used to simplify this beforehand, but we're letting the calculator do all the hard work for us, so we'll go ahead and press enter here. And I think I missed a parentheses. This isn't quite right. Sine of x got squared, but the 11 piece of it did not, so let me fix that. So we want to move this parenthesis to here. So now I've got the quantity of 11 times sine of x being squared. Okay, there we go. So small change. That looks better to me. It's displaying appropriately, and we've got our answer in decimal form as well. So here again, I didn't realize that this mistake, or that this answer was wrong. I had no idea whether the prior answer was correct or not. I wasn't worried about seeing this. I was just checking the way the calculator finished the math for me, and I realized that I had a parentheses in the wrong spot. Since we wanted pi times radius squared, I needed both the 11 and the sine of x to be squared. And I did not see that here with this prior computation. So I am happy with this exact answer and approximate answer, and we can report that on our test as well. Again, I'm looking for the setup and the results. I'll go ahead and stop this video here, and I'll make another one for the next ones, next pair when we start talking about the washer and shell methods. Thanks for watching.